Morning, all. I'm talking to you from MLC Central in Humble, Texas, beautiful Humble, Texas. And today we're going to talk a little bit about how to inspect both pre-owned and new foundations. And just be aware that, as the slide says, that's up on your screen, that this is, I actually put a negative in there, a double negative, reporting a la TREC. Well, TREC doesn't license you to do this type of inspection. This one is strictly for you and your client in terms of the reporting. And today we're going to talk a little bit about how to reduce your liability and your responsibilities, because you need to remember that the foundation is the basis of your customer's investment. And we need to do it right. So in order to do it right, you got to know what you're doing. So we're going to take a little trip around the forms today, learn a little bit about them. We're going to look at how to inspect them and what to look for and what shouldn't be there and what should be there. And then interspersed in there, we will also be looking at some pre-owned homes with stuff on the outside, and we're going to learn why it is showing on the outside of the forms, or maybe why the foundations do what they do in terms of function. So anyway, with that, we just get right into it. Basics of post-tension foundations, which is our focus today, is that most post-tension slabs are hybrids. Actually, they have the cables that get tensioned, and we will talk about that a little bit later, but they also have rebar in them. And the whole purpose of a foundation is to be able to support what's on top of it based on the soil conditions underneath it. And so if you have moving soils underneath, and we have that all over Texas, some places not, but many places it moves very badly or a lot. And excuse me, the rebar will help to stiffen it, as well as the post-tension cables, but the post-tension cables also provided a little bit of flexibility. And in fact, that flexibility has given it its nickname of a floating foundation. The install and inspection of any foundation starts with plans. And plans require you to be able to read plans. So if you can't read plans, this is not a course on how to read plans, but you need to learn that. Otherwise, you won't know what you're doing. These plans also need to be prepared by a structural engineer. And we do engineering based on the IRC. Or excuse me, we engineer foundations based on requirements of the IRC. There are also prescriptive install instructions in the IRC, but rarely are they ever followed. Most everybody goes to an engineer. Concrete is not poured ever, it is placed. And we'll find out a little bit later as we go along that concrete is a big, heavy substance that pushes things around, plastic, dirt, cables, and we'll see that as we go along. Once the foundation is ready to place concrete, it's not possible for them to wait for you to get there for a couple of days, because you need a little lead time. Time is of the essence, and you need to put concrete in it as soon as possible, because it begins to deteriorate as soon as it's completed. Just remember always, this is the basis of your client's investment. So it's a big deal, and you're taking on a lot of responsibility for your clients. This is not just going out and doing something and collecting a check. You have a responsibility to your client, as you always do. Okay, there's some of the hybrid. There we can see the red cables, and they're crossing. It looks like one's down in the bottom of a ditch. That ditch is called a beam, and we'll cover that in a little while. And the two that cross are on top of the beam, and then you have some rebar on top of that. Please notice that rebar crosses those cables And it should be tied to those cables as long as it's when in contact with them. I'm gonna move fairly quickly because we got a lot of material here to cover. Oats. This is a picture of why we use an engineer. And sometimes even the engineers go wrong, but this is the Bay Bridge between, I believe, Delaware and Maryland, I think. And they had a little bit of an issue here, as you can see. But we don't just wing it. We depend on engineers and surveyors and a lot of other people to get these foundations in properly. Okay, a peek at the plans. Notice in the bottom left, we have an engineer's stamp and a signature. That's a big deal. If it doesn't have an engineer's stamp and signature on it, it's not engineered. I don't care how pretty it looks or how close to this it looks. Notice on this one, it says, it's a little bit off the thing, but something 002 Aurora Park Lane. So in addition to the engineer's stamp, it also needs a specific address. And why? And the reason why is because the engineer, excuse me, should engineer the foundation for the amount of stiffness or support capability that it needs for that specific lot and specific soil type, so it can resist movement in the soil. The first, let me backtrack here. This is just an example of the foundation. You can see the overall on it. It's got plenty of dimensions on it, and it's got some dotted lines that run latitudinally and longitudinally. Those are the beams that I talked about a little bit earlier. We'll get into that a little more as we go along. This is the second sheet of a foundation plan, and it's called the beam detail. And each beams that I just mentioned are detailed in here because there's different ones. Obviously, there's different ones in a garage than there would be in the middle of a foundation, not so much in terms of depth, but in terms of how they work when you have, say, a car stop, a step down. Okay, this is what I meant by place, not pour. Now, I was a builder many years ago. I've been inspecting for about a little over 31 years now. But 15 years before that, which of course makes me about 29 now, we didn't use these pump trucks, but all of the builders use these pump trucks now. It was a brief funny story. The concrete truck you see on the left, they were required to jump the curb and get right up to the form that you see the guy in the kind of a turquoisey shirt on in the back there, and or in the center of the picture, just past the skiddo can. That's a Corpus term, by the way. Skiddo cans were born in Corpus Christi, Texas, in case you didn't know. Anyway, it gets pretty muddy out there when you're in construction, as you probably know. And sometimes those trucks had to make a run and leap at the form. And at one time we had one who jumped the curb full blast, and those barrels that the concrete comes in from the plant, those are not attached. Those are just sitting on ball bearings, really. And this thing jumped off the truck and goes, because they're turning, mixing the concrete, goes rolling across the field. It was pretty spectacular. It didn't have cell phones with cameras in them then, but I wish we had. It would have been a great shot. Anyway, these pump trucks move the arm around to where they can actually place it where it needs to be. Honestly, they do give a little better mix too, because I may be preempting myself, but when the concrete is mixed at the plant, it goes in that big hopper at the top on the back of the truck, and they just dump cement, sand, aggregate, and water in there. And then the truck is off to wherever it's going to put the concrete or take the concrete. They don't mix it. So it's all about the mixing in the truck. And let me tell you what, they are not turning that barrel very fast when they're driving, a little bit, but not very fast, because it'll tip the truck over. So when they get to the location, as you see on the picture here, they need to turn it high speed and give it a chance to mix. That is the difference between good concrete and bad concrete many times. And sometimes it'll come out of that truck unmixed and it'll be dry as a bone on top. And the concrete finisher will go, add 10, add 20 gallons of water in there. And that just weakens the concrete. So sometimes it's just as simple as turning the truck when it gets on site. Probably this is something you won't do as part of your inspection, but just you need to know that there's a difference between good concrete placement and bad.
Hey, Mike, got a question.
Sure.
All right. Someone's saying, are you checking all the dimensions per plan whenever you're doing a pre-pour inspection?
Stay with me. I'll get there, but it's a good question. And it's one for myself that you know what, I'll just take a minute and answer it. The only dimensions I take are those beam depths, because those are the critical ones according to the engineer. It's my sense, and I do put this on the report, it's my sense that the builder needs to take some responsibility in this and do some of the simple measurements, and that's one of them. So no, I don't measure the outside, but I do measure where the beams are and the depth and the width of those beams, because that's absolutely critical for carrying the weight of the house that you're going to put on it. Okay, garage car stop. That step up on the front porch that you see there and the garage are both created by 2x4s and 2x6s, where the concrete steps up and steps down. That's something that you want to look for. Early on in my building career, thankfully it wasn't my house, the concrete makeup guy that does the form sets, he form set the garage about 5 feet too short. Nobody noticed it until after the concrete was in, and it was very hard to park a car in that one. I think they finally sold it to some guy that had a couple of Volkswagens. That metal thing that's sticking up right in the center of the second, well, in both pictures, I guess, is a hold down, and it goes into the concrete just right after the concrete is placed, and it goes down in and anchors into the concrete. And after the frame is installed, it's nailed to the frame so that it holds the framing to the foundation. That's a wind resistant construction issue. Okay, this is a pretty simple plan right here. You can see that the dotted lines going across the page and up and down the page, those are the beams. That's a typical ID for a beam. And then each one of those arrows comes out, that's a cable placement. And those are all things that you check. And you see on the bottom left, there's a cross through that section. That is an add-on section that's like an option that the buyer can, I have no idea what it would, probably some kind of a room, maybe a study on the front end there or something. And there's what it looks like on the ground. Now this particular, the wood that you see is called forms. Everything else is called makeup, with the exception of the plumbing that you see sticking up. Now, across the top of this, it's pretty unusual to see wire mesh. That's 6x6 wire mesh that stiffens the foundation even more. And they use it in areas that are real susceptible to bending. And I don't think I've got any slides on this. Maybe I should add them for the next time. But the best or the most structural foundation shape is a square or a rectangle. It's got no bends. And then when you make the footprint into an L, then you've got a plane of weakness going across the elbow of the L. And then one that's a U-shaped, that's got two planes of weakness for the same reason. So many times they will stiffen it, the U's and the L's in those areas. Those red and white small pipes that are sticking up next to the shorter white PVC, those are water lines. Okay. I want to reinforce that you're not going to be capable of inspecting one of these guys in a short 2-hour learning session. You need to have a PTI certification, Post-Tension Institute certification, in order to get your basis. It also would be important for you to have a mentor. In other words, somebody that you ride along with, almost like an apprenticeship program, to where you can actually see, translate what's on paper to what's on the ground and what you see many times on the ground. And one final thing, and this is, I have a good friend inspector who lives close, and he calls me a lot and says, you know what, I'm arguing, Mike, with this builder about this and so and this and so. It doesn't necessarily have to be a foundation issue, could be a framing issue, because we both do those as well. And what he has done is put himself in the position of an intermediary between him, between his client and the builder. That's not your job. Your job is to observe and report. Please remember that. It's just a spiraling loop. You have no enforcement power with the builder whatsoever. So you just have your client there, explain to him why you're calling stuff, put it on the report, and let this report speak for itself. If the builder decide, and this goes really for any type of inspection, but if the builder or the seller says, no, I'm not going to do it, or no, I don't have to do it, just because the state of Texas has adopted certain codes doesn't mean there's any enforcement. And certainly it isn't you. So don't get in that position, because it's a no-win. Okay, materials. These are the materials that go into a post-tension foundation. We've talked about the forms. The cables are also called tendons. We have anchors for each end of the tendon. We have wedges on one end. We'll learn what that is. Chairs that hold it up off the plastic and in the middle of the concrete. And we have cat heads that it's a good place to take care of the stray cats in the neighborhood. I guess we'll learn more about that. We got a moisture barrier, that's that plastic. And we've got, again, the forms and the floats. And the floats that step up into the house from the front porch and the patio, and maybe even a garage or a sunken living room, maybe a sunken shower. Those are all called floats. Okay, you start out by scraping the vegetation off the lot. It's a requirement of the code. It's a requirement of PTI. I'm sure they were talking about weeds that are waist high, but scrape the vegetation is scrape the vegetation, and there you are. Then you put a footprint consisting of wood all the way around. One of the things that you'll want to check for is to make sure it's braced adequately. They will then fill this form with bank sand. And that's not clay, and that's not sharp sand, that's not playground sand. That's actually defined as sand off of a river bed. And it's more soil than it is really sand. And the reason why is because it compacts really well. If you put clay in there over time, that will compact. And after the concrete is placed, it will leave voids underneath the concrete that we sure don't want. We want this foundation to be sitting right on the dirt. Right just to the left of the brick there, just to note for you, that those 3 stakes, one of them's behind the brick, and with the horizontal boards on them. Those are called batter boards. That's the very first thing that the form sitter will do. He'll put one on each corner of the footprint that he's fixing to install, so that he has the outside walls and corners all marked. And then he puts string lines between them. Kind of an ingenious, very simple, been used for eons, ages and centuries. A lot of what we get on our home building, you should know, comes from the mason profession, which of course is very old. Okay, we're looking at a ditch here, or a beam, and you see the form board on the top. So we have an exterior beam right here. There's a few things that I want you to notice. That rusty looking thing at the end of the red cable, up and down red cable, is an anchor. And if you look closely, you can see a couple of big honker nails that nail it into the form board. And just between it and the form board, there's a black thing called a pocket former. And that is the thing that you sometimes see on a pre-owned home, where you can see in there and the cable is exposed. That's also the end, called the live end, that they do the post-tension stressing or tensioning. You see that this beam has a bottom cable and a top cable. So the engineer feels like he needs to have this super stiff. So he's decided 2 cables in this beam. And at the bottom, you see a chair. That's that black thing. And it's wired to the cable. That's important. And it's sitting straight up between the cable and the plastic. Now, if you are not in a beam, but yet you are on the plastic, you only got about 4 inches of concrete layered right there. So it's really important that that cable be suspended right in the middle of that 4 inches. And that chair provides that support where it doesn't move. If it's not tied, that heavy concrete will blow that chair right out of there, and then that cable will be sitting on top of the plastic, and there will be zero, and I mean zero, no reinforcement in that area.
Hey, Mike.
Yo.
Okay, we got a question. Can
Yo.
you point these things out? Can you move your mouse to indicate exactly what you're talking about to them?
I do have a mouse. Can you see my red mouse, my white mouse, guys?
Can you make it larger?
I don't know.
Like a speck on the
let me see what I can do here.
And someone was asking, how do you know the overall thickness of the slab?
Okay, I will ink color. Let's just, I don't know if this will do it or not. We'll see.
Yes, it's the size of it more than the color of it, I think.
Yeah, I'm looking to see arrow options, visible, hidden, automatic. I'm not seeing anything. It'll make it bigger, Paul.
Okay, that's all right. Just do. There you go. You can see it a little bit there. Yeah.
Okay. All right. So anyway, get out of here. What is this action here? Now I don't have a pointer anymore. Oh, bummer. Okay. Oh, that's what I'm talking about. Look at that bad boy. We got it covered. You can tell I'm a better inspector than I am a PowerPoint guy, right? All right, let's see.
So the overall thickness of the slab is generally how thick on post-tension foundation?
I got you. Okay, when you arrive, you see a nail right there. There will generally be, and we may have a picture of it as we go along, but there will generally be a string line from the top of the foundation on one side, diagonally across it. That's how you tell. You will be able to measure easily with a tape measure, excuse me, how deep the foundation's concrete will be. It goes right across the top of the foundation.
Okay.
Let me get, it goes right about from here.
Can you show again what the chair was so that everyone will know what the chair is?
Sure. Okay. The string line would be attached maybe right here and go right straight across to here. So you can easily see And this is something that the makeup man is required to do. Okay, this is the chair. That black thing, okay? And then it's tied right across there. You can just barely see it. And then that's the anchor, and that's the pocket former. We'll look on the outside of this pocket former in a little while at another picture. Also, I want to call your attention to the water in the beams. No, big time. Dilutes the concrete that sits in that beam. And remember, the beams are the load-bearing members of this foundation. The exterior walls will all have a beam underneath them to carry that weight, and that, you know, is many times brick or stucco, certainly siding, and then the framing and the interior walls that carry loading also have beams on them. You saw that it's kind of a grid work on the previous slide. Anyway, if they have water in here, the water needs to be removed before the pour begins, the placement begins. And there's been so much water in there that we've had cave in, which also needs to be cleaned out. So those are two items that you would certainly call on an inspection. Any other questions there, Paul? Paul went to get a cup of coffee.
No, I had to unmute myself, Mike. I'm sorry.
It's okay.
Let's see. I do have a couple of questions popped up. What's the piece of rebar in the trench?
Good idea. You can't see it too well, but there's a wire tie that holds that cable off the bottom of the beam. Again, it needs to be suspended in the beam, concrete.
Yeah, if it sits on the bottom of the dirt there, it's not giving you any enforcement for the
Right.
concrete at all.
Right.
Someone's asking, should that moisture barrier be in the grade beam?
Oh, good question. It probably is. I think I see some dark right here. It would not go up this side because remember, this is the exterior of the foundation, but it generally goes to somewhere in that area. All of this should be covered. But I submit to you because of the rain, this is a very messed up foundation.
Okay, I had one other question for Mike. Said, how do you know the pour is solid and not honeycombed?
How do you know?
Yeah.
Well, it's placement first. So let's get our terminology. It's very important. We never pour, we place. And you don't. And the way they take care of that, though, when they're placing the concrete, is they have what's known as a vibrator. It's kind of a little motor that's gas powered, and it's got a long wand on it. They stick it down into the concrete, mostly in this area right here along the exterior walls of the foundation. And it literally vibrates the liquid into the rock so that you don't have the honeycombs. The other way that's more common and cheaper is they come along the outside and beat on the outside with a big sledgehammer. And it just moves the soup, if you will, in the concrete into the pockets that we call honeycombs. Is that it?
So are the beams not reinforced in this picture?
The beams are reinforced. That's reinforcement, and that's reinforcement. Absolutely. That's on the top of the beam, and that's the bottom of the beam. And the answer is absolutely.
Another question says, often see two cables run close together instead of one at the top and one at the bottom. Is that correct?
Close together it depends on the plans. The engineers do some strange stuff. Sometimes you'll see rebar down here instead of a cable. Sometimes you'll see two cables down here. So when you see that type of thing going on, where it's not just one on the bottom and one on the top, you can pretty well know to yourself, it's not something you need to tell anybody, but that this is soil that really moves a lot. And the engineer was struggling to put enough reinforcement into this concrete to where it will not move. It'll be as stiff as possible. Please remember that concrete in and of itself is not structural. It's only structural after you have reinforcement in it And in the case of cables, it's not structural until this cable has been tensioned, and this cable has been tensioned, and this cable has been tensioned. And we will talk about that in a little bit.
Okay, it says someone's asking, how do you address the deficiencies with the builder? Do you do it right then, or how do you handle it?
No, we talked about that. You're not the intermediary. If you put yourself in the intermediary spot, I can't help you. You know what's right and you know what's wrong. You put it in your report and make that available to your client and ask him to pass it along to the builder. If the builder, it's so simple. If the builder decides he's not going to do it, he does not have to follow any of your instructions. The reason that you do these inspections is the same reason you do a TREC inspection. It's to provide conditions of the property to your client, period. It's not to fight with the builder. It's not to try to talk him into it. But your answer, I mean, he's going to come back and he's going to go, no, we're not going to fix the cave in. And so what your simple response to your client is, okay, if you're not going to do that, because remember that you've already explained to your client why it's important, because the beam depth is no longer, I don't know, 28 inches. It's now 26 and 25 in this area. So this is a weak point of the foundation. So your client should ask for a letter from the design engineer stating that this is okay to be here. It's not your call to say it's okay to be there. You are not an engineer.
That's good, Mike. Hey, we're getting a lot of questions popping up, so that's good. You're getting a lot of interaction here.
Good.
One question is, how long does it take for the concrete to cure before they should start framing?
It's an opinion thing. Okay, most of those plans we looked at, they say a lot of things, guys and girls, a lot of things. And one of them is no masonry. Another thing is many of them will say it's okay to start framing. My humble opinion, I mean, if you've ever looked at a frame package drop on the ground, it's a pretty big, dude. It's a lot of weight. And to put that much on an unreinforced foundation is a big mistake. And if I were buying a home from any builder, that would be in my contract with them, that they would do nothing until the tensioning of the cables occurred. But they do it every day. They put a frame on it. And frankly, as a builder, I put a frame on it stupidly because I didn't know at that point. I've become a lot smarter as an inspector than I ever was as a builder. I'm maybe embarrassed or happy to let you know. My humble opinion is nothing on it. But okay. The engineer's rule.
One more question on it, Mike. Says, when the guys take a wheelbarrow and haul concrete to the back of the building and dump it, or pour it rather, is that pouring or is that placement?
And what is this concrete going to be eventually?
Could be a patio, could be a back porch attached to the house.
Okay, it's it's a combination of the two, to be honest with you. And truly, if it's a patio that's not monolithic with the foundation, it's not structural anyway. If you look at, if you're fortunate enough to be there and watch any of them place it, seldom is there any reinforcement. It's usually just 4 inches of concrete anyway, so it's not structural.
Okay, another one says, please clarify to folks that a letter from an engineer is not valid unless it's stamped with their seal.
Duly noted, and absolutely right. Any engineer, if he's going to make a statement, he needs to be willing to put his stamp and his signature on it. Good point.
And shouldn't the engineering drawing specify the wait time for concrete?
For wait time for stressing?
Well, it says for the curing.
Oh, for curing. Well, the truth be known is foundations cure for 30 years. But in order to be cured enough to tension, the engineers, every plan that I've ever seen says 7 to 10 days. They gain about 60 to 70% of their strength in the first 7 to 10 days, and about 90 to 95 in the first 30. And then they spend the next 30 years doing the next 10%.
Okay, and someone's asking how soon should these tendons be stressed?
7 to 10 days.
Okay, and someone's saying, should we report a deficiency if the chair is not tight or laying, or if it's laying on its side?
Absolutely.
Okay, it says if we do not do it, how do we make sure the foundation is flat after it's placed?
Read that one more time, Paul.
I'm gonna put in my words, Mike. It's hard to read the statement here. They
Okay.
want to know how you know the foundation is flat after they poured it or it's level.
Well, that was pretty easy. There is no level foundation in the world. It's poured by human beings, and there's no straight edge that'll span any foundation that I've ever seen. Honestly, you're going to laugh, but I have seen concrete finishers who used a fire hose made out of rubber filled with water so it was wet or weighted, and walk it from one side of a foundation to another just to get it as flat as possible. But there's no such thing as a perfectly level foundation. As we proceed on, I'm going to show you a few tricks to make sure that at least we get started in that right direction. But maybe I should take just a moment and remind you that you're not going to be here during the placement of the concrete unless your client wants you to. And I will do that. You know, if they want me to watch the pour, I frankly work for a couple of engineers that I go out and watch the pours. And oops, I just committed a sin. I said pour instead of placement. I watch the placements, and I sit there for 3 hours and I make pretty good money doing it. And then I go on to the house. But that's for an engineer who wants the concrete watched as it's being placed or maybe poured, depending. But for a client, you're going to be there like the day before the placement. And so you're not going to necessarily watch the concrete go down, watch what happens to these chairs, supervise the mixing of the barrel. Not that anybody would ever pay attention to you as a third-party inspector because you've got no enforcement powers. Just kind of remember what your place is here. You're not an enforcer. But what you can do, and what I do all the time, is I personally want my clients with me for all inspections, including especially for this one. And these guys, these clients that are buying a new home, they are hungry to know all about their home that they can find out 90%, 99% of them. And so I kind of explain as we go through, kind of like I'm doing to you, the reason or the things that I'm calling out as deficient and why. And so when they come back, I encourage them to come back on the day of the placement and see if they're all corrected. They've got enough knowledge to see if they're correct, and they've got the report that I generated to see if they're correct. But, you know, divide the line between when you're going to be there and when you're not going to be there, because you're not going to supervise the pour. And even if you did, the concrete finishers would go, huh, who is this gringo?
All right, good answer, man. Appreciate the interaction. Got 4 more questions that's popped up. Said, so broken bricks are no good for chairs?
Broken bricks are no good for chairs.
In other words, they have broken bricks placed to hold the tendons up instead of chairs.
Creates a void in the concrete. No.
And what about the plumbing pipes where these tendons go across? Do they need to separate them?
Yeah, they do. And let's hold that one until we get to that picture.
Another one says, I've seen multiple foundations poured and they are framing within 3 days. When I asked, they said the concrete is infused with a chemical to speed up the process. Do you have an opinion on that?
I do. As a builder, I never poured with any admixtures. That's known as an admixture, and got no idea what kind of chemical that they put in it or not. But I can tell you, any admixture will weaken concrete, and I would never buy a home from any builder that used admixtures. Just period. I described concrete to you. It's aggregate, about 1.5 inches. It's sand, it's cement, and it's water, and that's it.
Okay, another question. During the first year of new construction, I saw cracks on the foundation slab. What is a possible root cause?
Good point. And we've all seen those, most likely. It could be, okay, for the first 7 to 10 days, if you kind of recall what you've seen out in the field, seldom do they ever put a grade down that will run the water away from a foundation. You know, in pre-owned homes, we always want the water to move away. Excuse me. Same thing in our situation right here, especially here, because the foundation is not reinforced in that first 7 to 10 days. And then you put the weight of the frame on top of it, and it's liable to move even more so. And so when you're assessing cracks in a foundation, whether it's young or old, it's the same criteria you should be using when you assess one on a pre-owned home. Grading and drainage is your biggest cause of foundation movement, period. But you know, if a misinstalled engineered foundation that's again not installed correctly, or has water in the beams or cave-ins like we're looking at here, is also problems. On a pre-owned home, on a pre-owned home, you don't have the nicety of being able to have that information. But when you go back on a frame to do the framing inspection, if you do those, you know what condition the foundation was the day you inspected it, and then you have hopefully your client who went and watched the concrete placement itself and can tell you what was and was not fixed, and encourage them to do that. They can be your assistant inspector. Absolutely.
Okay, Mike, so whenever we find something serious during our inspection, what's the buyer's recourse? What do we recommend?
Okay. When you find a deviation from the engineer's plans or the PostTension Institute's guide to installing PostTension foundations, there is no good or bad. It's wrong or it's right, period. There are no worse or better. Now, I say that, and I have found foundations where they're missing a cable. That's probably at the top of the priority list there. I found foundations. Let me get my pointer here. This is so cool. I got my pointer. Thanks, Paul. Where I stand right here and I sight down this wall right here, and I can tell it's high here and low down here, or I can tell this whole area bows out. I mean, those are big deals too. We've all been on pre-owned homes where the brick does not always sit right on the brick ledge. Sometimes it goes inside the brick ledge, and sometimes it's hanging off the brick. That's what's the word I'm looking? Not straight forms are what allows that to happen. Structurally, that's probably not an issue, but cosmetically, it's going to be ugly, because the bricklayers, they know how to make a straight line. They use a string line, and it's fail-safe. These guys, nobody checked it. You know, another thing, just so that you know, most builders right now, unlike when I was building, they use turnkey contractors to go all the way from dirt to foundation placement. That sounds like a real cool thing, but the builder has relinquished, I'm sad to say, all responsibility and control from the basis of their client's investment. And they put it all in the hands of a subcontractor, which is kind of scary. And I can tell you, doing engineering inspections, that those guys are absolutely way off being perfect. Way off being perfect.
That goes to my next question. Someone's posted, Mike said, the state requires a builder to be on site for all placements, right?
Nope.
Yeah, a lot of times just the concrete people there. They don't have an engineer on site. They don't have the builder on site. No one's watching them.
Well, your famous thing, Paul, will be that the client will say, Well, the builder said he's going to have an engineer on site during the placement of the concrete, so he'll take care of all this stuff. Read my lips. I know you can't see him, but he is not an engineer. He is an engineer's, we'll call him a helper. I'm not an engineer. I've been doing this a really long time and I've got the certifications to back me up. But most of these guys, you know, are $50 an hour guys. And they go out there and they just sit on the hood of their car and watch the gray stuff go down on the ground. Not a good thing.
Okay, one of the engineers online, Mike, says that clay bricks for supports are not permitted.
Say that one more time.
Clay bricks for supports are not permitted.
That's in line with what I just said.
The question popped back up again. Apparently we didn't answer it good enough. It says we report serious deficiencies to the clients. Then what is the buyer's recourse? What do we recommend?
Well, the buyer's recourse, and especially in this day of the seller controlling everything in these real estate transactions. I know you guys have seen it. It makes me crazy. 3-day option periods and such. To walk away from the sale.
Okay.
In fact, I will tell you that I do expert witnessing as well. And there was a foundation that was cracking and moving away. And it was from a big box builder. And he refused to give these guys their money back. I mean, it was the crack in this foundation was literally an inch wide. It was one section of the foundation was moving away from the other. I did not do the foundation inspection on this one. This was a finished home. And so the guy took him to court and he made a lot of money. So did I. Go ahead.
Sounds like Flex Seal could have solved that issue.
Yeah, yeah. A little bit of glue, Elmer's.
Okay, it said with reference to hairline cracks and new foundations, can you specify if it's an actual crack or if it's just shrinkage?
Good question. That's the favorite word that the builders use, is a shrinkage crack or a curing crack. Cracks that have any gapping at all are cracked all the way through. There's no shrinkage, there's no curing, they're cracked. We see them all the time. That's a normal, something is a normal observation for us. What they're doing really is what makes the difference. If you look at a crack, you kind of get away from it and look at it and see if one side of the crack, the concrete is not level with the other side, or you see it gapping, the deflection that I just talked about, or maybe it's even offsetting. One side is lower, of the crack is lower than the other side. Then you got some issues going on.
Wow, Mike, I keep getting questions, man. I've got 2 more good ones for you.
We may not make it through this, Paul.
I'm telling you, what specifics should we look for and report if we see a builder is installing a concrete encased electrode rebar in the grade beam? In other words, if you got a rebar for the concrete encased electrode, is there something we should report?
Yeah, tell them it's there and ask them to confirm with their electrician that this is made from rebar, from ground rod material, which is not rebar. And if it needs to go 8 inches to the ground as specified by NEC. I am personally.
And I'll let you get back at it here. Well,
Okay.
I had 2 more pop up. Do you make plumbing stub up locations? Builders break out concrete to relocate plumbing all too often. If we don't measure plumbing, do you tell your clients that you're not measuring where the plumbing fixtures are going to be going?
Yes, I do. I do not do that, and I do say that on my report. And I also say, I put it on the back of the builder. The builder has to be responsible for some of this. Now, I've already told you that they're not, most of them being very responsible until they get to the frame package. And they go, oh my gosh, we've got to break out. And they think really nothing about breaking out, unfortunately. But if you ever look at a set of plans, there's not an engineer in the world that will allow for breakouts. And any breakout should be done under the supervision of a structural engineer.
Okay.
One of the famous ones, let me just tell you, we'll get to it a little bit later, but you put under concrete water lines, underneath the concrete and electric lines underneath the concrete, and sometimes gas lines underneath the concrete, and actually sometimes a downdraft vent underneath the concrete. All of those should be on the plans, and all of those should be per engineer specs, and none of them should be allowed to be installed after the concrete is already placed, because it bastardizes the concrete or the foundation.
Mike, we got one more question, and then about 2 minutes, we need to take a break.
Okay.
Does a rebar supporting the tendon in the beams need to be taped with duct tape? Is it taped with a contact with the earth or above the vapor barrier?
Okay, I'm going to assume that they're talking about. Oh, sorry. I'm assuming we're talking about that rebar, and it does not need to be taped. It is not in contact with that cable right there. And frankly, its job is done once the concrete is placed. So if it could be pulled out, you could pull it out, but nobody pulls it out. It'll just rust away.
Okay, good. All right, man, you got some more. Well, I'm gonna mute myself, and you've got about a couple of minutes before we take a break, so go ahead.
Okay. All right. We've preempted, guys and girls, we've preempted some of my pictures. So when we get there, we will probably spend less time on them. That's what a cable looks like. 7-strand, 1/2-inch steel cable. That's it. That is a specification that's made by the engineer, and that's something that you should check. Those are a pile of anchors. Those ones, we saw the rusted one in a couple of pictures back. And we'll look at those again. Notice the nail holes has 2 nail holes and then one for the cable to go through. Those are wedges. We'll talk about those, just kind of identifying things for you as we talk about them later. That's where the wedge goes. See, it fits neatly in there. And we have 2 ends of each cable. One is the dead end, and that one already has the wedge installed in it with a cable sticking out of it. The live end has no wedge. It's got that black pocket former sticking out of it, and that's the end that we'll do the tensioning on from. All right, there's a look at a beam. We got a lot of water in this beam, as you can see. We've got no ties on that chair. So as the concrete pushes it away, this is gonna, probably the next one's about 3 or 4 feet this way, and that whole thing will lay right on the plastic, no bueno. All right, let's continue on with this photo here. So, because you can see the cable running to the anchor, to the pocket former, and through the form board. And then you see the cable tail coming out this way. In a little while, we're going to see a stressing machine that attaches on this end of it and pulls this to about 20 kips. That's, you don't want to be in the way if that thing pulls loose. That's a lot of kips. And to our engineer friend in the audience, you can define a kip for us. It's somewhere in the neighborhood of PSI, but there is an equation to get from one to the other. And frankly, I don't know what it is, so whatever. Up here, you see we have a cable running down to the bottom and one running on the top, and you see they both come out. So both of those will need to be stressed. And then you can get a better look at the plastic as it comes down and goes underneath the grade beam. And there, how the water has messed that one up. But one final thing before we moved on from this is, remember that this is all bank sand underneath this plastic. So when you fill these with water, it seeps or wicks right up underneath here. And if you've ever gone swimming in a mud bottom pond, you'll know that your feet start sinking into the mud. That mud moves, and so does this. And that's why I said that as soon as it's ready for concrete, the concrete needs to be placed with no waiting, because it immediately begins to deteriorate. Okay, let's go to the next one. Oh, we got a close up. This is the dead end, okay? And notice we have the cable taped all the way up to within 1 inch of the dead end right here. And then we have some big old honker nails that are attaching it to the form board. We need 2 of them always. And notice there's 1 inch in between the form board and the end of the cable, which is pooching out there. It's full of mud because this got rained on, but this form got rained on. You have done pre-owned homes where you've got little red rust spots on the foundation wall. It's because that guy was right up against there and it's rusting, and that's not a good thing. Look at the cave in here, pretty bad. Tie, wire tie. We love wire ties. Okay, here's one that's not nailed very well. And when this one tries to be stressed or tensioned, this is going to pull out. Here you can see the cable end hanging out, and there's that little wedge we talked about right there. Those the dead ends come from the manufacturer already installed, so they're good to go. And for some reason, I got 2 pictures of that same thing. Okay, let's talk chairs. Everybody needs to be able to sit down, but not on that bad boy. And we're going to talk about cat heads too. That's just a name that they call these things, but it's a vernacular. And I'm talking to you primarily in vernacular that everybody on the job site should understand, including our friends, the engineers. There's a cat head in action. Now, you remember we saw the cable tails sticking through a couple of pictures ago. That's where these guys clamp onto this so that when the concrete tries to push this around inside the form, it won't be able to. It'll be stopped by this. However, this needs to be right up against there, and this needs to be right up against there. Otherwise, it does no good at all. That would be a deficiency. We have a form board here that's not secured very well. See how this one is a different plane than this one? And that's what, when you see pre-owned homes, that's what you see when you have variations in the sidewall of the exterior beam of a foundation. Okay, we got a side view of a pretty much finished product with the commander hanging back there. Hello, Commander. Anyway, you see the cables running this way and running this way. There's that string line that somebody asked me, how do you tell whether there's 4 inches? That's how you tell. You just walk up to that bad boy and put your tape on it and see if there's 4 inches between it and the plastic. All of these cables are taped all the way to the edge. That's a good thing. We should maybe say why these cables have a plastic around them. And the reason why is to allow the cable inside to move when it's tensioned. That cable grease is some nasty stuff. Do not get it on your clothes. You will pitch those clothes immediately. It is so nasty. Whoops, let me move that out from it. Okay, now we're going to talk about beams, sunken areas and step downs, gas and electric water drains in and under slab, piers underneath slab on grade, and drainage trenches. And there we go. Okay. Sorry, I'm moving a pop-up box. Whew, this is nice and bright. We can kind of tell what's going on here. There's your string line running across again. This is a chair that's not tied. There are a few ties at the intersections, but the ones in between are not tied. So when the concrete comes rushing across, it's going to push that thing right out of there. It'll be gone. Here we're beginning to see some cables very close to the pipes. Those would have a chair installed, but to where the bottom of the chair is against the pipe. And then it, of course, would be tied, because when those cables are tensioned, they try to straighten up and they can crack pipes. And that chair allows a little bit of margin of error or leeway for that cable to straighten out. This cable right here seems to be kind of roller coastering across. This would be a cable that's not installed with enough what I'll call hand tension. It needs to be hand tight. And this very well could be one where those loose cat heads that we saw a few minutes ago, or a couple of slides back, have not been put up against the form, and that's the reason it's so loose. But again, when that cable is tensioned, all of those bows are going to try to straighten out. Also, this is not generally in engineer's instructions, but generally speaking, these cables should go under and over and under and over and under and over. This one doesn't. It was laid all on top. So they didn't. It's just, I will say, an industry standard or good workmanship. I don't know that it necessarily makes a lot of difference in structure. It's just a better way to do it. There we see a drain pipe crossing the beam, which is allowed, but we have to have another larger drain pipe on top of it as a sleeve to allow some movement between this pipe and the concrete. There's not one there, by the way. That is a tub bucket. That's that hole in the concrete that you see when you look underneath a tub, if you're lucky enough to have an access port on a home a pre-owned home that you're inspecting. Boy, there's a cable that's real close. Come on. Okay, there we go. All right. You remember that bridge that we saw that didn't meet? That kind of looks like it might be that bridge that we didn't meet. That better be on my engineer's plans, or I'm calling it. I question whether this engineer should have made this a very gradual beam that would actually meet. And I frankly don't remember whether it was wrong per the plans or not. But there's a pretty good example of what I would call out as a deficiency if the plans didn't say it could do that. Your plans are your guideline. Go ahead, Paul.
I do have a couple of questions popped up here.
Okay.
Get back where it was. I think I lost it. Yeah, let me go down. I lost my spot there. Gas lines, do they need to be in conduit and have a vent when they're in the slab?
The vent is on the exterior wall and in conduit, yes.
Okay, how far from the end of the cables or the tendons can you use duct tape to cover it without the plastic casing?
1 inch. Oh, how far from the end of the cable? Well, the general rule is a foot or less. Otherwise, you need to put another piece of sheathing on it.
Yeah, and they can cut the sheathing and put it on where one's been missing or something, can't they?
Yes.
So can you go over more about the cat head, what it's doing, and why it wasn't butted up to the form that you mentioned earlier?
Remember we talked about how wavy this cable was right here, okay? The reason is because it's not hand tensioned, not machine tension, but hand tension when they install it. And it became even looser because the cat heads that they put down here on the end, when it was installed, are not butted up against the form. So it has plenty of play. This actually could have been 6 inches initially. And then as people moved around and adjusted cables inside, it could have pulled down to here. It really should have been up against the form board all along.
Okay. Let's see, where to go? We got that one, got that one. Another, someone said that the tendons are stretched to 33,000 PSI. I don't think that's correct.
It's a matter of kips and it's up to the engineer, and he'll have it on the plans. It's not something that we necessarily get involved with. I am there when after they have stressed, when I'm working for the engineer that I work for, excuse me, but I'm not there during the stressing. Generally, I have been, but generally I'm not. So it's not something you need to worry about necessarily, but we'll talk about that in a little while.
Okay, let's see. Let me. Okay, I think you've answered them, Mike. Thanks.
Okay. All right. Here's a very patriotic foundation. And this gives a pretty good example of a patio on the back of a house. Excuse me, you'll notice how it starts at 2x4s here and goes down to 2x6s here. That's because you have a patio that slopes to drain to the yard. And that's good. And this one has a brick ledge all the way around it. That's his flat board right here. So you'll have brick on this patio. Very fancy house. You never want to step on that board, ever. It will move. It's only nailed. You want to step on that vertically installed 2x4 on the 2x edge, or a 2x6 or whatever it might be on the edge. Boy, they sure got colorful on that one, didn't they? There's your electric line. That's going from the outside wall to an island, and it will be an island sink. So you'd have to have power to it. It is missing the water, however, which also needs to be installed and popped up right here. This is one of those trenches that I was talking about, and you can see how it's not. No, I'm sorry. My bad. This is not a trench to drain the foundation. This is when I arrived, the plumber had been there to put his sewer. There's your sewer clean out right there, and it comes out here, and it needed to be open. This goes down probably 12 or 15 feet. It's a wonder that's not considered a hazard. Somebody falling in that, a kid could drown. Anyway, it's full of water, and it is draining the foundation anyway. You can see it's not draining it very well, though, and it's full. I think this over here is the trench that they put in to drain the rainwater. And maybe we'll get a peek at that in just a minute. Okay, inspecting beams, tendons, tub buckets, cat heads, chairs, risers, undisturbed soil, and EGWD. I don't even remember what that is now. What is that, Paul? Who knows? Oh, I know what it is. Electrical, gas, water, drains. I made myself an abbreviation. I don't know what it is. Okay, this was a house that Edward Robinson asked me in his absence to come and take a look at. And it was over in the Spring Branch area of Houston. And it wasn't draining at all. So this one was like, really? This had a number of different complications. One was it wasn't high enough for the eventual finished floor to be able to even drain to the street. But the other thing was it was not capable of holding concrete yet, because it would have been completely diluted. And in addition to that, all of this water right here, remember, is seeping into this, and all of this subsidence is this pad or plateau going away. This one's going to have to be the cables removed, the plastic removed, and completely reworked. Probably heightened if I had my way, but that was up to Edward. If you're out there, Edward, this was a treat. I got a good picture for the class today. And I'm telling you, it was bad. It was terrible. Lots of cave-in. I think we looked at this picture before. Cave-in. All right, there's a chair. How about that? They put a chair on this one, bless their hearts, but they didn't tie it. So we'd like to have it tied. Here's a drain pipe coming across. You see we have an opening in the moisture barrier, the plastic. That's no-no. It should be tarred and taped. so that water doesn't get down or the concrete doesn't get down inside here or bugs don't get up, any of the three. It also is missing a sleeve to go across here. Now these drain lines cannot go into a beam and run with the beam. That's huge no-no, because where it's going to go back into underneath a plateau or a pad, it's going to have the ability to crack when if any movement takes place, and on this end too, where it goes in. So that would be a big no-no, and that would be a deficiency that you should call. And I think we've preempted some of these pictures that I'm going back to by needing chairs here, 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 on both sides of this tub bucket, and on this side of this tub bucket, and on that one. This one I'd need a lot of chairs. A root. We don't do roots. Roots got to be removed at the time of the makeup. They just don't mix well with concrete, and they place or displace the concrete where there ought to be, and reduce the strength of our foundation. No roots.
And my couple questions. Is duct tape allowed to be used to seal the plastic sheathing overlap?
Yes.
Is a moisture barrier required under a patio or garage floor?
Under a garage floor, yes. If the patio is monolithic with the foundation, yes. If it's just an independent foundation, no.
Can you speak about when termite pre-treatments are, how they're done?
Sure. It's an opinion question, guys. I think it's a marketing ploy, but at this stage is when they're done. They come and spray it on top and go and have a nice day. They charge about $300 for it probably. And it, in my humble opinion, does no good at all. It's a little bit like the, excuse me, the treatment, the green stuff that you see on frames that goes up the framing about 2 foot. I don't know that it does any good, because I think its half-life is so short that it just doesn't last long enough to be of any value. But it sure looks pretty and impresses all the clients. It's a little bit, in my humble opinion, I got a lot of humble opinions, by the way, like those little tubes that go in, you see on the side that the pest control guy can come and pump pesticide in through the walls. Well, if you don't have a sheetrock nail or smart aleck framer or drywaller or insulator who doesn't cut them, they probably work pretty good, but I think the chances of that are probably slim.
Yeah, I agree with that. Another question is, are builders hiring you to protect them from the foundation contractors?
Let me say this first. Notice that this cable is laying right on the plastic. I would have called that as a deficiency. And the question is, are builders hiring me? No. As I told you, the builders, and I mean every single one of them, because I do about 50% brand new homes is my mix. Every one of them really does not even look at a lot until it has a slab finished on it, a concrete slab on it, when they're ready for framing. So they just lay it all back on the contract, the turnkey contractor. I'm ashamed to say. Back in my day, if I, as a superintendent, left a job site during a concrete placement, I would be fired.
Yep, that's not the case today. Since this is not a TREC inspection, do you still use the term deficiency?
Absolutely. It's a good word. It's a solid word.
Is the inspector responsible for drainage issues if the pad is dry at the time of the inspection?
I have a note on there that talks about the potential for rain, and all of the items that we've talked about so far that surround rain, including the concrete needs to go down as soon as possible. So if I'm there on a Wednesday and it's done and they're not pouring till Friday, well, I mean, inspectors are always really cognizant of weather conditions. And if I see any rain in the forecast, I'm going to say that. But my report also says what needs to be watched out for. And if they're pouring it after a rain, or if they pour it and there's water in the beams, it's going to be the concrete is going to be substandard. It's just going to be diluted. It just can't help it.
Okay. When, if ever, would you advise a client to request the foundation be cored to determine the specified compression strength has been achieved or exceeded?
Well, it wouldn't happen at this stage. It would happen probably at the frame stage, and that one I was telling you about where the crack was coming unglued. just to kind of give you some other observations that were made. The top of the concrete was all sandy and it was coming off as you walked across it. So it was obviously a bad mix, and the foundation was not staying together. I mean, it had a real rugged crack going front to back that was gapped about an inch. I could see the dirt underneath it. There was no plastic underneath it. And I advised the client, and I don't do this often, but I said, you probably need to make sure that your attorney is going to be able to win this case, and he needs to tell you what it is he needs to win it, because this is not looking good. You need an engineer out here right away, not the design engineer, your own engineer.
Okay. Another one of our engineers online today said the Summit hammer test is non-destructive for PSI estimates.
Good. I'm not familiar with the protocols of it, but I will take his word for it and mark it down. I'm going to look into it. Thank you.
Okay. The moisture barrier only have the bottom of the beam in this picture. Is that okay?
That's exactly the way it should be.
Okay. So another one says they've seen this moisture barrier, like in your picture, go all the way up the outside area of that beam and stick outside where the slab will be. The moisture barrier will be showing after the slab's poured. Is that okay?
It is not. And that builder has not looked at the engineer's plans.
Okay. What type of inspection form do you use for phase inspection?
I made my own. It's actually one that you can see on my website. If you want to go look at sample reports, I believe I've got one on there, but it's one of my own design. It follows the format roughly of the TREC inspection, but not completely. So you can go take a look at it if you want to. I'm sure nobody in the audience will plagiarize, will they, Paul?
No, I'm sure they won't, Mike. It won't be posted online either. Right. All right, that's all the questions I got right now, Mike. So go ahead.
Okay, here we go. I have no idea how far through this we are, so we're in our last hour, so we better, let me know when we get to 30 minutes, Paul, please. Okay.
Yeah, we'll do, Mike.
Okay, thank you. Not sure, oh, you need to count the, I should read what I've written on there. Count the latitudinal and longitudinal. I'm not sure latitudinalism, I think that was a word that I made up. Longitudinal is, so that's a good word. Anyway, count the cables, make sure you've got the appropriate cables according to what the engineer has said. Engineer is our guide on this. You don't have the ability to say, well, we're missing one cable, or well, we're missing one beam. That's not your place. You are absolutely as prescriptively guided as you ever have been in your life on this. No room for oh, that's okay. We don't have a cable here. No, sorry, not your call. We looked at this wavy cable before and talked about it, so we will skip past that. And the cat heads, we have discussed that, I think, adequately. One of the things that I look at when I cruise up to a foundation is, hey, we got cables sitting out in front. Where are we missing cables in this foundation? It's kind of a heck of a clue for you to look at the cable count and look at it real closely against the foundation plans. There's a real close-up of a beam detail beam. And let me just grab my deal. See, it says 12 inches wide here. And it says 30 inches deep on this beam, okay? So this particular foundation needs 30 inches of concrete this way and 12 this way. That's the first thing that we look at. Also notice that the cable does not go straight to here. It goes down a little bit. And it's a 1/2 inch tendon cable size. And it also calls out the vapor barrier. There's a vapor barrier coming down here and stopping right there. Undisturbed soil. Undisturbed soil. Okay, just a brief one. This has always made me crazy. When you go into a subdivision, you see that generally speaking, the lots all drain to the street before you've put anything on them, like a foundation. And the streets are deeper than the lots normally, if the developer has done a good job. So you go, where did all that dirt go when they dug it out of the street? And if you watch one being developed, you find out it went up on the lots. That's not my definition of undisturbed soil, but every engineer has on their plans saying this foundation will be placed on undisturbed soil. Compacted fill, that's that bank sand I talked about, but undisturbed soil here, because remember, this is your weight-bearing member. This is for all the weights coming down and being translated into the soil. And yet they do it every day, and the engineers allow it to happen. So that's a conundrum for me that I just haven't been able to reconcile. Just thought I'd give you the conundrum to carry with you. Okay, we got to tie down the rebar that we talked about, but we got to keep it up in the concrete, not on the plastic. Tub buckets. Okay, let me see if I've got one. No, I don't think I have one. Okay. All right. When you look at a plan, a foundation plan, you will never see a hole in the foundation where the tub drain goes down that's this wide, ever. There's no hole in foundations. There's not. The engineer has said that there's no hole in the foundations. And the reason why is because he expects the moisture barrier to go underneath it, as well as the concrete, 4 inches of it to go underneath it. You will forever see these tub buckets laying right down on the plastic because, I mean, nobody enforces it. They look at me with crossed eyes like a deer in the headlight look whenever I say this when I go out there. But then I show them the plans and there's no hole in the foundation plan there. Oh my gosh, well, we've always done it this way. Well, you've always done it wrong. So, and I'm courteous. I just say, well, we're just following the engineer's plans here. So let's do it right. It keeps the bugs and the water from coming in. You will recall on pre-owned homes, when you're lucky enough to have an access panel behind a tub and can look at the bucket, that's a great way for termites to get in, especially if there's water leakage from that drain. We don't like that. We don't want that. Always tie the wires. Anywhere where you got a chair or a cable coming together, tie that bad boy. Now notice that nail and that nail seem to be a little loose. So I'm going to submit to you that this cable needs to be pulled this way to provide an inch behind this thing between it and the form board. Otherwise, we're going to go get those little nasty rust spots on the edge of the foundation wall that we see a lot of times in pre-owned homes. That's a colorful plastic there, isn't it? Ah, we got exposed cable right here. Look at that nasty grease on it. Do not get that on your clothes. I'm telling you, don't do it. Don't do it. Excuse me. Chairs every 4 feet with 6 inches, within 6 inches of beam. Okay, what am I talking about? Okay, every 4 feet, you're going to put a chair at least. and within 6 inches of any beam. So it doesn't fall off onto the plastic, obviously. See, that one's not, that one's not. So it comes very close to the plastic there. Okay, this is a float. This is like probably the back of a garage where it steps up there. These cables, strangely enough, have the ability to float. And concrete being heavier than they are, it'll not only float them, but push them up. So they will many times be showing, not many times, but every once in a while you see them showing on a pre-owned home right at the step up. We invert a chair and put it underneath here and tie it. That's how we prevent that from happening. Also notice that this is laying on the plastic, and it looks like the plastic, if you can kind of, I'm not sure you can tell from this perspective. Let me see if I've got a better picture. No, I don't. This slopes down to get under this step, and it should be continuing to slope down all the way to this edge. That's one of the reasons why it's laying right on the plastic here. The other reason is that there's no chair there. And there's a chair needful right up against the plumbing pipe riser. And there's a pipe going between the two, but it's not taped, and there's no sleeve on top of it. The sleeve should have all of this stuff on it, but it should be, you should be easily be able to tell that there's a pipe covering a pipe. And this sleeve just needs to go from one side of the plastic to the other. So you should have no problem identifying that it's there or not there. One other thing, when we have a cable going underneath this bad boy, we need an inverted chair there as well. Upside down chair. Ooh, this is a cluster. I think we need a few more chairs and a few more ties and a little less wood. And some ties on the chairs there. And this needs to be up off the concrete, tied up off the concrete. We need some work on this bad boy. Okay, EGWD that I couldn't remember what the heck it was. Mind is a terrible thing to waste, is it not? Okay, we need these for islands, island sinks, floor receptacles, and the drain lines need caps on top of them. So we'll take a look at that. That's so concrete when it's placed, is not placed down the caps, down the risers. See, there's a nice little cap. Boy, that would be neat for one of those concrete trucks to just dump that little hose right into there and fill that bad boy up. Not good. Lovely, we have a chair. This is a pigtail.
Hey, Mike, I'm sorry to interrupt you. We've got about 10 minutes left.
Oh my gosh, what happened to my 30 minutes, Paul? You messed me around. Okay.
Don't you remember I told you?
Oh no, I don't remember. Brain damage. Okay, this is water coming into a house. This is actually a really good idea. It prevents the water from being exposed to freeze on the outside of the house, goes right up into the house, into the walls, into warm areas, we hope. Okay, there's a cap. I'm going to move a little spryly because I want to make sure that I've covered everything. We've covered a lot through the questions. There's the underside of a foundation where it had to be replumbed. This was a cast iron house from the 60s to begin with. Kind of an interesting look at the reinforcement that's laying on the bottom of the concrete doing zero good. There's a plumbing and that looks like a gas line coming up into an island. Water line. Electric line under slab. Those are anchor bolts that we put in to anchor the framing to the concrete. 7 days after tension, and we've talked about that. Let's skip into that. Here's what the tensioning devices look like. It's just a press, and it's attached into the foundation, and it just literally pulls it back. And before they do it, they paint it so you can tell how far that they pulled it back. Even at that, we're kind of trusting that they're doing that. That's what it looks like connected to the what we call an anchor. And after they finish and the engineer comes and checks it, they cut off the nails and they cut off the cable. Sometimes we see both. And then they go back with non-shrink grout and grout the hole. One of the difficulties is grading and drainage. As I told you, that's one of the premier causes for foundation movement. And the way they're spot building, this one's established and this one's not. So when this one gets established, one of the two is going to have a problem most often. That's the way it looks. You've seen that before. That's the way it's supposed to look. We'll do that later or another time. Okay, we talked about cracks. That's got a gap. That goes all the way through. That is a crack. That's not a curing crack. That is not a settlement crack, or excuse me, that is not a curing crack or a drying crack. It's a crack. That's a crack. And you can see it's gapped enough to put my card into it. That bothers me. That's cables showing through. They should not be showing through. So that weakens the foundation. That's the end of your dead end showing through where they didn't put it far enough back away from the form board. And there's one that's hiding behind a concrete patio. That's what it looks like before they put grout into it. You see the wedge in there. They've supposedly already stretched that, we hope. And that's one in an existing foundation that never was stressed. There's no wedge back there. You can easily see what a wedge looks like. That's it. Get down on your hands and knees and get your screwdriver out. That's a pre-owned home. Boy, that one never has had sufficient stressing. Oh, what are we doing here? Can't see what that guy is. Okay, there's one coming unglued. That's one of the indicators. Oh, I don't know why I've got that. Let's see. Oh, that one's pulling loose. So that indicates some foundation movement. We're, I guess, moving on to pre-owned homes. That's not a good cut in that barge rafter. Actually, that's a hip rafter. That's a lousy cut. That actually needs some bracing underneath it, I think. My humble opinion. Okay, corner chips. This was a blowout that took place, and it's way more than a corner chip, but there's your typical corner chip, and it's because there's no moisture barrier, thermal expansion barrier / thermal whatever between the brick and the mortar and the concrete on the edge of a foundation. Very typical. As long as the cable is far enough from it, is usually not a settlement issue. Boy, I got to work on those pictures. Okay, there's another one hanging out. Boy, that one's heavily rusted. That cable is probably going to require rethreading. In other words, they pull it out and replace it. That one's looking pretty bad. That one's looking pretty bad too. You can see the edge of it. And that's rebar on the edge of a foundation, and foundation or concrete is porous and water goes through and it hits steel, rusts it, and rust expands when it gets rusty and it pops the concrete out. It just does it. Okay, piering, there's some pictures of it. Oh boy, different kinds of piering. Blowouts are always pretty exciting. That's a blowout. That's where the cable release tension in a big, quick hurry, and it's like an explosion when that happens. This I saw in a Kingwood house, carpet raised. What the heck is all that all about? Well, there was a cable experienced a blowout, and when it did, it ripped up the concrete. Get your nose underneath the furniture, take a look around, okay? Do your job. It is what we do. There's a anchor that doesn't look straight with the exterior wall, and it's going to be a problem.
Okay, Mike, we've got just a couple more minutes. I know you probably have a lot more slides to go, so.
I'll just walk through them. Go ahead. This is one where they're fixing a blowout. You got any questions?
All right, no questions. I was gonna say you probably ought to share, if you got your email address and contact information or something you post up on the screen, probably good for people to see because we've been being asked for your website so that they can get that report format that you use for these inspections.
I'll give you verbally. It's MLC, Mike, Larry, Charlie, inspections.com, period. MLCinspections.com.
Okay, good. Well, Mike, I want to tell you, it's a great presentation. I'm sorry we're not able to finish it, but time is out and we're going to have to switch over to the other presentation we've got coming up here at 10 o'clock with Don on roofing. So those of you that are online now, if you will, you are going to have to log out of this presentation and then at 10 o'clock log back in on the presentation with Don Davison for the roofing class. So with that said, Mike, if you got any of the closing comments, I'll let you do that and then we'll end the meeting.
Okay. All right. To do what you guys are and girls are here to do today is a very specialized inspection to avoid liability and do the best job for your clients. You need to have the certification to lean back on, and it's not code. It's a PTI certification, and you've got to have experience because frankly, even PTI doesn't provide you the experience to read plans and get in the engineer's mind and adequately do an inspection like this. So your best option is a PTI certification and get with an inspector who's competent in doing this.
Right, and PTI stands for PostTension Institute, for those of you that don't know. All right, Mike, I appreciate you're giving this presentation today. Outstanding.
Okay.
We'll close this. I'll give you just a couple of minutes for our attendees. If you have any comments on the class, if you'd like to kind of tell us how Mike did, put it in the chat box and we will watch those and listen to it. If Mike can improve on any areas, tell us what it is and we'll send it on to Mike. All right, thanks everybody for attending. And Mike, thanks again for presenting for us today.
Hey, y'all be good. Bye.
Bye-bye.